Hello, my name is Liz Lesher, and I have selected PhET interactive simulations to show you some technology that can be used in the biology classroom. I chose PhET interactive simulations because they are a very versatile program that can be used in almost all science classes and math to show real-world situations and ties in math and all sorts of wonderful things with that. It's really a very accessible way to do STEM in all of these classrooms. My goals and objectives for this lesson are just to teach you some of the ways in which PhET interactive simulations can be useful in the biology classroom. My intended audience for this video is fellow biology teachers, and of course the actual content of this is applicable to biology students. The two ISTE standards I will be referring to today are 4A, which is to dedicate planning time to collaborate with colleagues to create authentic learning experiences that leverage technology. PhET applies to that because the University of Colorado Boulder created PhET interactive simulations with the help of other science teachers, and science teachers are constantly developing these programs, working with Boulder, Colorado to load these. So in using them, you're actually already collaborating with other science teachers. The other ISTE standard that we'll be addressing today is 6C, which states create learning opportunities that challenge students to use their design process and computational thinking to innovate and solve problems. All of these simulations will present a real-world problem, and the students will develop a solution to it, or at least be able to manipulate it and learn firsthand how it works. So let me show you some of these examples. So my students just learned some basic chemistry. So we're going to do some of these basic chemistry labs. So here is the one on pH scale. pH can be a very abstract concept for many students, so it's really helpful to have a hands-on or at least simulated hands-on experience. We have two options here. We can either do micro or macro. Micro gets us to the level of the atom, and macro is basically what your eyes can see. So we're going to start with macro. So we have our pH tester, we have what the pH is actually going to be. We have a beaker with an outlet and an inlet for water. And then we have a pipette, which will continue to fill our container. So I would ask my students, what do we expect the pH to be? And of course, they're going to say neutral, so 7. Perfect, we got 7. All right, what would happen if we drain out all of this water and we add another liquid? So I would let them pick which liquid. Of course, they're going to choose vomit. They always choose vomit. So let's see what the pH of vomit is. The pH of vomit is 2. Now, what would happen if we add water to vomit? What do we expect to happen? Well, our pH is rising till eventually it would get fairly close to 7. All right, let's drain out all that vomit water because that's gross. And now we're going to add something basic. Again, knowing freshmen, they're going to choose blood. So we're going to fill it with blood. Blood has a pH of 7.4, which is higher than neutral. It's basic. So I would ask them, what do they expect to happen if we add water? So we add water and we see that the pH is going down closer to neutral. So again, this is just a very handy, you can do this as a demonstration, or you can just assign it to the students to explore. As you can see here, you can just load it on Google Classroom. You could even do this as a homework assignment. Give them a handful of questions. What happens when you do this? What happens when you do that? And that could be a homework. On the micro side, it shows us the concentrations of hydroxide ions and hydrogen protons that are in our solution. So right now we're at 7, so everything's neutral, but let's add some drain cleaner and you can see how everything changes. So it's a very useful, very concrete way of showing these things. So that is just one simulation. Another simulation I would like to share with you is molecular polarity. This is another one that can seem awfully abstract to our students. And sometimes having a example can really help out. So we've got several options here. I'm going to choose real molecules. No, I'm not, because it didn't work. I apologize for that. I'm going to choose 2 atoms. So if I can change their electronegativity, and it's going to show me with this black arrow where our charge is going. So obviously the A is less negative, the B is more negative. And I can change it up. I can make it flip over. I can change the electron density, and we can see how that works. And this is based on the shading of the poles. So again, it allows for some real good visual representation of the data, which definitely helps students in that computational thinking. This is not just for biology students. PhET also has simulations for physics, chemistry, or science, math. I particularly like the math simulations. I know this is not a math one, but when I discuss reading charts and graphs with my students and we get to the slope, I really like the slope intercept simulation here, because they can just type it in and see how it reacts. So if you have a higher slope, it's going to be steeper. If you have a lower slope, it's going to be shallower. And then it'll tell you, oh, you can't do that. So it's a very handy, quick, easy visualization. If I was going to do this on the board, it would take a long time to erase and redraw those lines, but here I can just do it quickly. So PhET simulations are really handy technology. I highly recommend them for all teachers. If you're not using them, you probably should be. Thank you so much. Have a great day, everyone.